Hi friends, welcome to our channel. Let's have a look at problem 3639, minimum time to activate string. This is a relatively new problem, and in this video we are going to solve it using insort, right? So first I'm going to read through the problem statement so that you can follow the sort process. So here we are given a string s of length n. And also, we are going to have a permutation of the numbers in the range from 0 to n-1 inclusive. So starting from time t equals 0, so we are going to replace the character at index order t in the S with a star. So here, a substring is valid if it contains a star. A string is active if the total number of valid substrings is greater than or equal to k. So we want to find the minimum time at which string s becomes active. If it's not possible, we are going to return -1. So first thing we need to notice is that, so after you finished all the time from 0 to time n-1, right, all the characters will be replaced by stars. Then every substring will be a valid substring. So you can count the total number of valid substrings, which is nothing but n times n plus 1 divided by 2, right? If that number is less than k, so it's impossible, right? You don't have a valid time. Otherwise, you will have a valid time. So you can look at example 1 and example 2 to do the analysis for the case when we have a valid time. For example, the output in example 1 is 0, and in example 2 is 2. So in our solution, we are going to print out some information after we finish the coding. So that way you can follow the details, right? So example 3 is an edge case, right? So if you replace all the x and y's into stars, but this string has a length 2, so overall they will have, let's see, 2 times 3 over 2, that is 3. 3 substrings is less than 4, right? So we return -1. So here there are some constraints, right? So especially the length can be as long as 10 to the power 5. So this basically tells us that we need to pay attention to the time complexity of the algorithm or solution due to the size constraint, right? So here k is in this bound, right? So here is a hint, right? Basically, you can use binary search. This is the one way. However, you're not exactly needed to use binary search. So here I'm using insort. So it's also kind of binary search, but we want to search the index, not on the searching of the time, right? So in some sense, it's the same. So now let's look at the main point. So the main point is that, so each time if we change a new index character to be a star, so for example, originally now we changed the position at index I to be a star, then we can find the left nearest and right nearest star positions or indices, right? So originally, if there's no stars, we can write L to be -1 and R to be the length, right? So the key thing is to track how many valid strings are created due to the add of the star, right? So actually, this is not very easy to count directly for valid substrings. We can use the complementary method, right? So basically, you can count the decrement of invalid substrings because all the available possible strings, which is a fixed number, which is n times n plus 1 over 2. Then you track the number of invalid ones, you minus this one, you get the total valid ones. Then you can compare with respect to this key. So originally in between L and R, there are R minus L minus 1 positions. So they produce, so every substring of this string will be a invalid one because it does not contain star. So it's still the number of characters times the number of characters plus 1 divided by 2, right? So this is the invalid substring. But if I add I, so the number of invalid string will be decremented. So for this, we can look at these two intervals, L to R to I and I to R. Both are closed intervals. So the left one create this number of invalid one. So that is the number of characters times number of characters plus 1 divided by 2. Same for this one. This is the number, right? This sum actually is less than this sum. So if you consider the difference, so this is the decrement of the invalid ones, right? So now let me write the code, and then we can further digest. So first I want to get the length. The length, so then the full possibility is n times n plus 1 over 2. In other words, if we replace all the positions to be star, this is the number of valid strings we can have. Let's check if it's valid or not, or active or not. So first, if full is less than key, right? So we need to return -1. We don't have valid time. So now let's using the above logic, right? So then what we are going to do, we have a -1 n. So we pretend that at this index and this index we have 2 stars, right? So then originally total invalid would be n times n plus 1 over 2, right? So now let's iterate for t this time. The index I in range, it's not in range, in enumerate order, right? Then I want to first find the L and R's, right? So in this we can find the insertion point of the index I. So this is the IDX is bisect left. So bisect left and right is the same because for the indices and the -1 and n, they must be different. So we are searching here and search this one, right? So we get L and R to be indices IDX -1 and the indices IDX. And then in order to prepare for the next round, so we insert this position. So basically we can call a binary search, let's say insort, right? Left indices I, right? So next we are going to track the change of invalid substrings. So this number is nothing but this d, right? So I just copy it here. But I cannot use this one, but just minus this one, right? So this is the decrement of this invalid substrings. So invalid, so total invalid will minus equals d, right? So and then what? So because this number is let's see, yeah, that's the minus this one. I would say, yeah, this number is larger than this number, so we minus this one. So the total number of invalid ones is decreased. So now we check if the invalid would be total possible minus total invalid, right? So if invalid is greater than or equal to key, we can immediately return this t. So actually we have already checked this case, so we always return something. Therefore we don't, this is the end of the code. So we can first run it. It passes all the cases. Now let's submit that. it passes all the cases. So now what I want to do is, because there are some explanations here, so we want to confirm these explanations. What we do is this. So we can do a print. So temp and invalid, right? So we can get for case 1. So we only print 0 because when temp equals 0, so the count of valid substrings is 4, right? So for example 2, so you can see when t equals 0, the count of valid ones is 3. When t equals 1, it's 5. And when t equals 2, that is 6. Because 6 now equals this one, so we are going to return 2. Well, for the last one, so because it actually does not enter this for loop because of this logical check, right? So with that said, I guess that's the main coding part. So if you are not very familiar with insort, you can check out the bisect module, right? This is a very useful module. So there are basically several methods: bisect, bisect left, right, and bisect right. Although also you will have so here we are using insort left. So you will let's see, what's the problem? Yeah, you will have bisect insort left and bisect insort right. So this way, so basically bisect left will find an index such that to the left of the insertion index, all the numbers are strictly less than the number we are going to compare, right? So this is the bisect left is in corresponding with insort left. Similarly, you can check this. So if you insert an element and get an index using bisect right, it's corresponding to the left, all the element is less than or equal to that element, right? So you need to check the details, but if you have some understanding of this module, so solving this kind of problem is rather neat. So here, I just want to comment that. So here using insort is like using sorted set, right? Sorted set. So essentially, we need to track this the envelope interval, right? And then check the delta. So with that said, I hope that you have gained some understanding and you can manipulate the code and write your own version. With that said, thank you for watching.